I'm going to go ahead and spend just 1 minute introducing our first talk of the day, which is very, very exciting. So our first talk today is going to be entitled Securing Cloud Deployments, a Red Team Perspective. And so this is a talk that I am super excited about because number one, it's being given by somebody I've got a great deal of respect for in the industry, Matt Burrough, who's a senior penetration test lead over at Microsoft. And if you're thinking to yourself, man, where do I know that name? I've heard that name before, even if you haven't been a definitive red team type person or even a cloud person for too long. Matt sits right at the convergence of that because he is actually the author of a book on this exact topic, doing pen testing in Azure. And so it's funny, when we saw this talk come in, I was like, I had that exact thought. I said, wow, where do I know that guy's name from? Because I don't think I've met him in person out in the industry, but I've read his book and it's an awesome one. So I've got, again, a great deal of excitement for just, hanging out and listening to Matt give this talk because he's on the front lines of this stuff. I mean, you have to imagine a company like Microsoft where, again, you've got just a staggering number of resources. Certainly you've got this massive Azure environment that, is growing day by day. You've got tons of things going on out there. And, again, he's the one that's involved with that team that's finding those opportunities for attackers to potentially come in and, again, try to cause trouble and potentially wreak havoc. And the goal, of course, with any red team is for that not to happen. And so it's that offense informing defense. And the more of that we have, the better off I think we all are. So with that, I'm going to go ahead and move us into Matt's beginning slide. But Matt, take it away. Super excited to have you.
Thanks so much, Dave. Really appreciate the intro here. Let's see if I can take control. All right. So, awesome. All right. So, as Dave said, I'm Matt Burrough. Let's give you a quick intro on me and some red teaming, and then we'll get into some specifics from my team. There we go. Get video rolling too so you can see me. Awesome. So as Dave said, I'm a senior red team lead at Microsoft. Microsoft has a bunch of different offensive security work going on. I specifically sit on the corporate internal red team. So my job is to make sure that Microsoft is secure as an organization, just as many of you are out there trying to secure your organizations as well. Also the author of Pen Testing Azure Applications from No Starch Press, so you can look that up. Got a bunch of certifications, a whole bunch of Microsoft ones, as you might expect, but for this audience, probably the more interesting ones, GPen, GWAPT, those are great courses you can take. I took 545 about a year ago. That's a really awesome course for those of you enrolled. You're in for a treat. I've also got the CCSK, and if you want to reach out to me later, I'll be in the Slack channel, like they said. I've also am on Twitter at Matt Burrough, and I'm on LinkedIn with the username mburrow. So with that, let's jump into some content. All right. So I wanted to give a quick intro on red teaming and pen testing and my perspective on those. I know some people have different definitions. It's good that we're all kind of, talking at the same level. I'm not sure how many people here are offensive security folks versus defense or architects or things like that. So I'll just give you a little bit of background so we're all on the same page. So what is red teaming? Red teaming is offensive security research. So offensive, not in terms of we piss people off, although that does happen once in a while. More like a sports metaphor, right? We're playing offense, there's another group playing defense, and we coexist to make the security of the company better. Another objective we have is to model real world attacks. And so we're not just looking at the security of one system or looking for kind of a checklist of security items. We actually want to think like an attacker thinks and try to emulate that behavior. It's only through doing that that we can really test the full range of security controls and make sure everything is working in tandem to keep attackers out. We're also objective oriented. So again, we're not looking at, say, one web app and just saying, all right, let's find just the cross-site scripting vulnerability in this web app. We think how an attacker would think, what is someone attacking your company? What are they trying to get out of us? Do they want money? Do they want some, critical sensitive document, some kind of spec, source code? Any of those kinds of things. And so we'll we'll think an objective that we know an attacker is likely to be after, and then we'll figure out how they would go about going to get it, and we'll try to attack that path as well. We're complementary to other security controls. So we don't replace code reviews, we don't replace good security design, we don't replace monitoring or auditing, but we seek to enhance all those things. So during a red team engagement or during a pen test, we'll look at source code. If we get access to the source code, we're happy to look through it and try to find vulnerabilities there. But we're not going line by line doing a complete review of a package. We're looking for particular things we can exploit and move forward with. And now let's just discuss a couple of terms that kind of get thrown around. Some people use them interchangeably. They're not entirely interchangeable. So these are my definitions. Again, different people have different takes on these, but I'll give you my perspective. So vulnerability assessment first, that's looking for broad issues across your entire organization. Think of things like running Qualys or Nessus, looking to make sure the patch level of all your machines is correct, making sure there's nothing that's just known, easily exploitable. This tends to be done with a lot of automation. You'll build dashboards out, things like that. You want to burn down risk. You want to make sure everything is in compliance. That's great. That's just not what my team does. Certainly a key part of making sure your company is secure, but that's not where we focus. Then you have penetration testing. And for me, penetration testing is looking at one particular system or application or team and going pretty deep on the security and trying to exploit that service. So my team does a fair bit of this work too, where we're asked to take a look at a new application that's been published. Is the company using this securely? And we'll go through and see, are there any vulnerabilities in this app? If we find them, let's exploit them and see how far we can go. Kind of scoping ourselves to that one team or customer. In our case, we call them customers. They're all internal other groups that we're looking at. If you're certainly an external security company, you might be looking at customers that are actual customers, but treat it all the same. And then finally, there's red team engagements. The type of work we're doing on a red team engagement is similar to a penetration test. We're using the same methodologies, but the difference there is we're not looking at one particular team. Again, we're focused on that objective of stealing some critical document or some critical piece of infrastructure, gaining access to it or something like that. And so there we're really just looking to kind of take control of the entire environment and also make sure that the detections are working, helping out our blue team members. Let's talk about some of our team's goals. And I think these are red team goals pretty much in general. So the first one is to make the blue team better. Red can't exist without blue. There's no sense in having an offensive security team if you don't have a good defense already in place. We want to help out and make sure that all their detections are working, all their monitoring capabilities are working. We also want to have a good working relationship with the blue team, right? We don't want to be seen as just this adversary who's sitting, in a different building, who's terrible and making their life hard and burning their cycles and using up their valuable time, tracking us down. We want them to appreciate the work we're doing, to find value in what we're finding for them, finding any gaps where they're not seeing things that they should. To help that, we've actually been working a lot on doing purple teaming. And so purple teaming is the process of red and blue coming together, right? Red and blue make purple. And for that, we'll sit with them for maybe an entire day, and we'll go through recent campaigns that we've run and talk about things that were detected or things that weren't. We'll also bring some of our APT research, and we'll say, hey, we've seen a lot of this out in the wild. Our threat intel people have told us about this. Let's go ahead and emulate that behavior right now, right in front of you on some test servers. And you can look at your detections live, look at all the logs in real time, see if alerts aren't firing or they're firing at the wrong severity level, things like that. So helping out blue is definitely one of our primary goals. Another one is to find flaws before attackers do. Of course, we don't want any of our services getting compromised, and so we're trying to do these penetration tests and red team exercises, at a very regular cadence as products are released or services are stood up, just to make sure that, if there is an issue, that we're finding it first before it can be taken over or compromised. And finally, we want to prove that threats have real-world impact, and this is something that is a lot harder to do with a vulnerability assessment or sometimes even with a pen test, which is, you can show that, hey, this web app has a cross-site scripting vulnerability or a SQL injection attack or something like that. But an executive who owns that application might not understand what the impact of that is, right? They might look and say, okay, well, there's a bug, we'll fix it at some point, who cares, right? But if I can show, hey, yeah, this has this bug, but by using this bug, my team was unable to move through your environment and steal your very valuable credentials, And then with that, we could log in and steal this document that isn't supposed to be released yet, or take all your source code or steal your product code or something like that. Now suddenly there's real world impact, right? The management is very concerned about this, and they want to get that fixed. And so it helps just put the right context into the issues we're finding, making sure that they get the right treatment and the right priority. So if that's red teaming, what is red teaming in the cloud? Well, my team has existed for a number of years now, and we've done a whole bunch of assessments of things that are running on our corporate network, but we've also looked at a bunch of things running in the cloud. Microsoft has an entire offensive security team devoted to protecting Azure, and another offensive security team devoted to protecting Office 365 or M365. But those teams are worried about the product for all our customers, making sure it's secure. My team is worried about Microsoft's usage of those products, right? Our internal teams like HR or finance using Azure correctly. And so we find a lot of the same issues in those teams that you might find with your own customers or in your own company. And looking at these in the cloud, a bunch of things change, right? It's not just the traditional kind of red teaming pen testing that you might do or might have done 5-10 years ago. And so one of the first things that you need to think about is permission and authorization. So typically with an old school type pen test, you would need permission from the team you're going after and maybe from the legal department. But that was kind of it, right? You got their permission, you went ahead, you did your attack, and you were done. Now you're not just dealing with that team, you're also dealing with whoever your cloud provider is. And so you now need permission from the cloud provider to do offensive security testing in their environment, as well as from your customer whose data and services are running in that environment. Another thing you need to think about is that you might not even be looking at, if you're going after one cloud service, let's say, there might be more than one cloud provider involved. So there's a lot of middleware and things that run in the cloud. Maybe you're attacking a software as a service platform on behalf of your customer, looking for their data in that platform. But when you're doing that, that service might actually be running on a different company's backend. So you could easily imagine, your customer is using this database application. This database application is then hosted in Azure or hosted in AWS. And so you need to make sure you're actually getting permission from all the right groups doing that assessment, or you could find yourself getting detected and getting in quite a bit of trouble for running offensive security tools against a server from which you didn't have permission. So making sure you get that full range of authorization is really important. The next thing that's really critical to think about is your scope and your rules of engagement. And so here you have to think, are my rules customized and applicable to whatever agreements I have with the cloud hosting provider as well as my customer? So a lot of cloud providers will say you can do offensive security work in their cloud, but they might have caveats, right? Knowing that a lot of things in the cloud are running on shared resources, right? You might be attacking a web app for your customer that's running on a machine in Azure, but that same machine might be hosting 10 other different customers, different companies' applications. Might not be running on dedicated hardware. And so if you were to just try to compromise that entire server and take over all of it, you're now getting 9 other customers in there that you weren't expecting and don't have permission to test. So having very clear scope as to what's allowed and what's not is very important. Another thing to think about is the extra level of infrastructure that you wouldn't have traditionally. So in a old school, corporate focused pen test, if you're looking at, say, a web app, maybe it had a SQL backend. So you're looking at a couple of servers, a web server, a database server, and that might be the scope of the test. Now, if you have those things, they're deployed into a cloud, there's a separate management infrastructure that's allowing your users, your developers to log in and manage those things, stand them up, delete them, make modifications to them. And so you have to think about including all that metastructure into the test as well. And again, looking at the rules for your particular cloud provider on how much of that you're allowed to test or not. There might also be limits on tools. Certain cloud providers will say you can run certain types of tools, but not others. Or some of your tools just might not work in the cloud. Maybe they weren't designed with that kind of scope in mind. Maybe there are particular limits on licensing, different issues like that. So you have to be very mindful of all the tools you're going to run. There might also be other detections that you're not expecting, right? Things that were never caught when you were running them on a corporate network. Maybe now the cloud has all these dynamic detections that can pick up on some of the heuristics there and catch you much more easily. And finally, you have to think about reporting. Another thing we've seen in some of the different cloud providers is that they have requirements that if you find a vulnerability, you report it to that cloud provider. It makes sense. They want to make sure their cloud is secure for all their users, not just the one that you're testing. but make sure that you and your customer understand that certain things you find might have to be disclosed to this third party as well. All right, so that's red teaming in the cloud and some of the major things you have to think about in terms of its changes. So with that, let's talk about some of the things my team frequently finds. So I'll go through a few of these things that are kind of, we see all the time with different teams or different groups. One of the other benefits of being at Microsoft and doing this work is I get to meet with our customers on occasion too and talk to their security teams and see what they're seeing. And so I have some insights into things that aren't just Microsoft specific, but common trends in the industry. So I'll talk about those and those kinds of findings, and then I'll talk about a few things we recommend to help mitigate all of these findings. So the first is lift and shift gone wrong. And so this is something that we see commonly on teams that are first moving to the cloud, right? This is the kind of problem that you'll see when a group is first told, okay, hey, we're not buying you any more hardware. You need to start putting things into this new cloud thing, right? And so teams that have been a little slower to get to the cloud might still be going through some of these issues. There's actually a whole talk on this later today at 11:35 from Steve Turner. Don't just lift and shift. So if you're interested in this, definitely make sure you join for that talk. But some things we see are that controls that you used to think were sufficient aren't anymore, or just methods that you're using aren't best practice once you move to the cloud. So what do I mean by that? Like on a corporate network, if you're deploying a server and administering a server, maybe you take for granted that your corporate network is pretty secure. You trust all the controls, you trust the edge boundaries, your edge firewalls, things like that. And so because of that, you can do some maybe not best practice security work managing that server. Maybe you upload all the files to it using unencrypted FTP. And maybe you're still using Telnet and basic auth and don't bother having a firewall in it, all these kinds of things. Obviously, that's going to be a big problem if you're moving this to the cloud where maybe all those management ports and infrastructure are exposed to the public internet. You definitely don't want your passwords going unencrypted up to this resource anymore, right? So if you just lift and pick something up off your corporate network and drop it in the cloud and don't make any changes, that's one of the first things you might make a mistake on. Another thing that you miss out on is all the cloud first benefits. And so things like dynamic scaling, right? Let's say you run a retail operation and 10 months out of the year, your server sees 5% load. And then 2 months out of the year, you see 90% load, right? And so you scale that server, you purposely buy a server big enough to handle your crazy shopping season. In the cloud, you can dynamically scale up and down. And so you're not paying for that, platinum level server the entire time. You can pay for a bronze server until the end of the year kind of thing. That's really easy to do if you're designing a cloud native application that uses cloud APIs and knows how to scale. It doesn't work so well if you just pick up a VM and drop it in the cloud. And so you might miss out on that. You also miss out on, by not having scaling, the ability to kind of protect yourself from like denial of service attacks, right? If your app can scale up dynamically, it might stay up in case you come under a distributed denial of service. Versus if you're just one VM that you've lifted and placed there and is running, it probably will fall over just like it would if it was running in your own network. Another issue we see is taking other security controls that you previously took for granted when you move to the cloud, right? That might not exist. So who manages all the different aspects of managing your server and your service? Patching, that's maybe done through an automated system on your network. Monitoring, maybe your blue team is monitoring your server already. Are they still going to be monitoring it when you move to the cloud? Do they know that you've moved it to the cloud? What about security policies, right? You have GPOs that are being pushed down that were designed by someone in your organization applying all these password policies, different things like that. Are those policies still being applied once you've moved to the cloud? Are you still part of the domain? Are you still getting all those controls added? Maybe, maybe not. And if not, what do you have to do to go make sure you're applying that same level of control in the cloud that you were getting kind of for free when it was on your own network? So those are all things to think about when you're just moving over services. Another thing we see all the time is improperly configured storage. And again, there's another talk tomorrow. Actually, this one's at 9:50 tomorrow. Lily and Melissa are doing a talk on AWS S3 buckets. Same issues you see in S3 can also apply to Azure. All the cloud providers provide some level of cloud storage, and people can make the same mistakes in all of them. So it's important, regardless of who your cloud provider is, that you know about these errors and make sure you don't make them yourself. So The first one you hear all the time is stuff left open to the world that wasn't meant to be, right? By default now, I think all the major cloud providers are not allowing anonymous access. I think that's turned off by default for everyone. But that doesn't mean you can't go in and turn it back on. And so if the person who's managing your cloud storage isn't the person who's putting the documents there, there might be this disconnect. And so the person who set it up might say, oh yeah, of course we want anonymous access because we don't want everyone to have to log in to download our public files. But then the person using that storage might not realize that this is a publicly available storage platform and start putting up confidential data there. Doesn't take long for attackers to realize that, find them, download the files, and leak them. Another issue we see is key management. And so how are you accessing this storage? What authentication methods are being used? What are your keys? How are they used? Where are they used? A lot of times people will use one key, they'll use it across all their applications. They won't think about where they're using it. And then when it comes time to roll it, like let's say that key gets compromised, one of your applications has an issue, if you go and reset that key, do you know all the places where you need to now go put it again? Are you going to break a bunch of applications? Are you going to be so afraid that you're going to break other applications you don't actually want to roll that key? It's a really bad position to be in. So making sure you're doing key management correctly and keeping tight control of your keys is super critical when doing cloud storage. Another is that the permissions that you see in cloud storage might not be what you're used to, right? If you're used to an Active Directory domain with kind of traditional security controls and ACLs, the level of access that you get to this kind of permissions in the cloud is probably not the same. And I'll show you that in a minute. I'll give you an example with Azure file shares. Another thing to think about is encryption, right? Again, on your corporate network, maybe you don't care about this as much. Maybe the network has IPsec, and so everything's encrypted, so you don't worry about encryption on your particular server or service. But are you doing encryption at rest, encryption in transit? All cloud providers support these things, but you just need to make sure you're making use of them. Data retention. When you're working within your own environment, you might have rules around we need to retain data for X period of time for regulatory reasons. Are you applying those same level of controls to your cloud storage? And just because you can doesn't mean you should. We see a lot of different creative ways of using cloud storage. Some of them are really cool and some of them are kind of scary. One thing a lot of people are doing is running applications straight out of storage. You can run a web app, you can run like a website, a basic website, straight from your storage provider without having a separate web server. That works, but you lose a lot of things that you would get from having a traditional web server or a cloud-based web server, right? You probably don't get the same level of logging or monitoring. You definitely don't get the same level of authentication and those kinds of controls. So while those things are available through your cloud storage, it's probably not the best place to do that kind of thing unless you have a really specific reason for doing so and have really thought out why you're doing it that way. So this is an example from Azure. Again, I'm a little biased because that's what I look at most of the time. I've played with AWS and things, but my examples will be Azure specific here. This is me creating an Azure storage account and creating an Azure file share within that storage account. So this lets you use your traditional SMB like you'd use to access a file server on your network, but to access it in Azure. And you can see here the documentation says, okay, great, just do a net use and here's your path. You can see I've highlighted in red there. The name of my storage account that I created was my Azure file account. And so that's the name of the storage account. It then appends the file.core.windows.net, my Azure files. So that's the full path to the service and then the share I created within it. And then you can see it gives me a username here. The user is a user in Azure, and then the account name is actually the same as that storage account name, my Azure file account. It's not giving me a whole bunch of different user accounts here. It's giving me the base account for the storage account. And that password looks really strong, right? It's a whole bunch of random characters, base 64 looking, pretty long. But that's actually the storage account key for the storage account. So now I can go ahead and use this as a file share, but I'm using that super important key that has full administrative control, full read, write, delete access to everything in this Azure storage account. And I'm just going to go and put it in on my machine and map a network drive and use it like that. That might be fine, but I'm definitely not getting that same level of granular control that I'd have with a traditional on-prem file share. And so if you just think, oh, I can just take my existing file server, we'll just drop it in Azure, we'll convert it over to Azure storage, you're not going to get that same level of control and user control that you're expecting. And so just know that things that operate in the cloud a lot of times have different controls than you're typically used to. Secrets and source. So this is another really big one for us. As different web services are moving to the cloud. We also see code and configurations moving to the cloud. We see a lot more usage of things like GitHub, right? People posting their code publicly, trying to be more collaborative, trying to make it easier, especially now with people working from home. We want to all have access to this code that we're working on and be able to collaborate really well. That can be great, but it can also be scary if you haven't thought about what's in that code that you're now making public. And we see this a lot more too in the cloud where, again, we just talked about storage account keys. There's a bunch of different keys and passwords and things that you might have to access all these cloud APIs that your developers are putting in the source code because they don't know a better way to do it. And there are different ways of doing it, but they might not know it, right? And so just by putting those keys directly into source code, now anyone who gets access to the source has full control over all those cloud services you're relying on. And so are those secrets that they're then putting into this code getting exposed? Are they getting published up to GitHub? And if they are getting exposed, do you know how to go and actually remediate them? Do your developers know that just because they delete that secret out of source, that doesn't mean it's totally gone, right? Someone can look through the source code history and still find that secret. So it's not enough to just remove the secret from source. You actually have to go and roll that key as well. That's really important. Another thing we see a lot of like junior devs making a mistake of is encoding isn't the same thing as encryption, right? So they say, oh, well, I know I shouldn't put the password directly into source code or directly into this script. I'll base64 encode it. There we go. Now it's not the password anymore. Now no one can find it, right? And of course, encoding can be reversed by anybody. It's not encryption. It's not protecting that secret. It's just displaying it in a different way. And so attackers know this and can easily find base64 encoded secrets, de-encode them, and then go ahead and use them. The other thing that the cloud lets people do and is really attack at scale. Just like you want to use the cloud at scale, attackers are doing this too. And so this is a really, actually, sorry, it's the next slide after this. So this is an example of one thing that my team would do. Luckily, we're not finding this as much anymore as we've done a lot of good training and gotten people to not make this mistake. But you'll look through a source code repository and you can just do a simple query, right? I want to search for all the storage keys in my organization. I know people will call their key storage key a lot because of the example documentation might call it that, or that's what it's called in the API. So we'll use that name. I'll search for that. I know config files tend to store secrets. So let's search only in files with the extension .config. Here we go. Here's 100 matches. Here's storage account key. Here's the name. I can go ahead and take that as an attacker, go log in and start taking advantage of your service. So how are attackers doing this at scale? Well, like I said, you'll find these in GitHub. I really like this tweet from a couple of years ago now, but in a series of 3 tweets, this researcher demonstrated how they were able to use Google BigQuery, a service against GitHub, and they got free, trial version of BigQuery, so they get $300 of free credits, and then they put together this regex just looking for AWS storage keys, and there they go. They run it, and a second later, they've got 9,922 AWS keys. They then went through the process of validating those keys, calling the API to see if they would actually authenticate or not, and 7,953 were still valid. Again, this is 2 years ago. There has been some work. I know GitHub has done some work on detecting these secrets and trying to get them removed before they're up there for very long, trying to prevent you from making this mistake. I think AWS is also probably scanning, looking for these leaked keys, but I wouldn't trust anyone to go find my keys in my source code, right? Maybe I call them slightly differently. Maybe I format my code slightly differently, and the regexes that all these different security organizations are using to try to protect me aren't going to fire. I might still be leaking keys. So I would make sure I'm doing a thorough source code review and running all the tools I can to make sure I'm not leaking these keys out into the wild. You certainly don't want someone going and grabbing all your company's passwords and keys out of GitHub. All right, insecure network settings. So this is another issue we see quite a bit. When you move to the cloud, again, you're dealing with a new kind of network infrastructure. You probably have things that are public-facing, internet-facing services that you weren't expecting to be internet-facing when they were running on your corporate network. And so we see things like teams not really sure because the cloud is kind of this nebulous thing, right? If you're a database administrator and you're now moving your database to the cloud, do you know where all your expected connections coming into that database are? Hopefully you do. But if your dev team says, oh yeah, there's going to be this web app running in a different cloud that'll be reaching in and querying the database, make sure it has access. If you don't know where that web server is running, you might create way too broad a firewall rule to allow it in. Another issue that you might have is you might be exposing your management ports to the internet, right? Before, you didn't care if you had telnet open. It wasn't a best practice, but it was on your corporate network. Now it's exposed to the internet. Not good. And finally, and especially right now, we're seeing a growth in home IPs being added to firewall exceptions. As people working from home, they add their home IPs. They might not think about the fact that their home IP is dynamic. It's going to change in a day or a week or a month. Are they going to go back and actually remove it a month from now? Make sure that whoever got that IP next doesn't now have access to the service? Probably not. So here's what that looks like. Here's an example, screenshot I took of a SQL server running in Azure, and this is the Azure firewall settings for that SQL server. So here you can see a couple of issues in these rules. One, this is something we see a fair bit, is an allow all rule, and this is to get around that issue that we talked about of, I don't know who's supposed to have access, so I'm just going to give everyone access, right? I'm going to allow 0000 through 255, 255, 255, 255. This is terrible practice. It's like you don't even have a firewall. Actually, I think it's even worse than not having a firewall, and here's why. This might be someone actually attempting to circumvent the corporate policies just for their own benefit, right? You might say that all resources that are running in the cloud need to have a firewall. Great. You didn't say what the firewall rules had to be, so I'm going to put this in. Now I'm still in compliance. You can't nag me. If you do a query and say, are there firewalls attached to all my resources? Yes, there are. Great, we're in compliance, but you've completely broken the point of having the firewall. So now you can't even check that you're not in compliance because it looks like you're running a firewall when you're really essentially not. Another thing you can see here, we've got home. I've blurred out the IP address, but we see this a lot with developers just going in and adding, oh, I'm working late tonight. Oh, I'm working from home because of COVID. I'm just going to put in my home IP address. So don't do that either. Also be aware of what the other settings in these panes mean, right? Allow public network access, yes, no. That's pretty straightforward. Allow Azure services and resources to access this. Do you know what that setting actually does? You should probably look it up. If you don't, think about whether you want to allow all other services in, right? If this is a sensitive database, maybe you don't also want to have, say, Power BI having access to the database. So maybe don't just blanket allow all other cloud services to access your resources unless you really thought through what's in this database and what that means. All right, social engineering. Now, this certainly isn't limited to the cloud, but there are certainly cloud implications here. As users and administrators have their credentials out there, certainly phishing for those credentials is a popular way of getting access. If you're not properly monitoring your cloud, if someone gets access to your cloud resources, you might not even know that they got access. So make sure you're monitoring all those logs. We'll talk about that more a little later. Another thing that kind of aids attackers in the age of the cloud is brand impersonation. If you're not super careful with how you're using cloud services, maybe you're not redirecting everything through your corporate domain like DNS system, you might be pointing users to, all right, we have a new internal web service that we're using for all our HR stuff. To go get your benefits, go to, my company's benefits.azure.com or something. Kind of relying on using your cloud services DNS instead of your own DNS. By doing that, you're now training your users that, oh yeah, if I see something that ends in, azure.net or something that ends in AWS domain name, that's perfectly fine for me to go to. It's a trusted thing. Now an attacker can come in and register just one letter off from that, but still running on the same cloud provider and trick a bunch of users into going there, and it looks legitimate. That gets even more complicated because SSL certificates used to be a way that we used to tell users how to kind of prevent themselves from getting phished, right? If you're going to a site and you're not sure if it's good or not, look in the address bar. If you see the green padlock, it means you're fine, right? The site is secure, you're good to go. But now you've got SSL certs from Let's Encrypt that are free for anyone to go get, or just your cloud provider saying, oh yeah, we have SSL for every web server running in our cloud. Now you can't use that as an indication of whether or not the site is secure or not, right? Another thing we see a lot is improper service deprovisioning. So if you have one team that manages your DNS and another team that manages your web servers, another team that manages your cloud resources and billing and that kind of thing, you could easily get into a position where one team decides they no longer want their cloud resource and they go ahead and delete it. But if your DNS team set up pointers into that cloud resource beforehand and wasn't told that this resource is being deleted either because the promotion is over or it was just costing too much and we weren't seeing enough usage of it, we're just going to delete it. You might now have a official corporate DNS entry now pointing to an orphaned entry in your cloud provider. So this could be like a CNAME record where, foo.mycompany.com points to mycoolwebapp.azurewebsites.net, or it could be just a regular IP like an A record where, mycorporateservice.corporation.com points at 1234, where 1234 is an IP address in your cloud provider. Once you've released those resources in your cloud provider, those resources can go back into a general bucket where they're available for anyone who's a customer of that cloud provider to use. And so if an attacker sees that, hey, I can go grab the IP address 1234, but hey, there's this still existing A record pointing to it from your corporate DNS servers. I'm getting traffic from your company. Now I can stand up a phishing page there and no one will know the difference. It looks totally legitimate. They actually went to your real corporate domain, but are now going to my malicious page. So make sure when you're doing decommissioning work, you're not just decommissioning the service itself, you're decommissioning all the DNS and other infrastructure around it at the same time. Otherwise you can get into the state. Confusing authentication and authorization. So this is a big thing we see quite a bit where junior developers will say, hey, we want to let everyone in our domain into this web service. So we're building this web service. An easy way to check is, hey, are you in the domain? Cool, you're authorized to use it. But they don't think about, oh, that also means all the vendors that we gave accounts in our domain now have access to this. Maybe they shouldn't. We also see issues where people are determining role through user settable fields, right? If you have a cookie in a web app and the cookie has a value that says admin equals 0, if I just go into my my browser and I modify it with the browser like debugging tools and set that to 1, am I now admin in your web app when I shouldn't be? This happens. We see that with other identity fields too, right? Maybe not the admin field, but if you let me set my own user customizable name in your app and you don't do any kinds of bound checking on that, have you validated that I didn't change my name from my name to our CEO's name and now send out a message, using the messaging feature of this app to all users that they need to go click on this link? That could be a really bad day. And gray clouds. This is a term I'm using for clouds that you don't have full visibility into or full oversight of. What happens when your company isn't moving to the cloud quite as quickly as some folks on your team might want you to? Or maybe you're moving to a cloud that your users are not completely satisfied with, right? You have people who came in maybe as part of an acquisition or something. They were used to using Slack, and now you're saying, hey, we're not going to use Slack anymore. We're going to use this other messaging app. Maybe they're going to go ahead and say, yeah, I don't like your new messaging app. I'm just going to go ahead and stand up my own Slack server anyway and talk over here. That would not be super good for your standards and policies if Slack doesn't meet your requirements. And if your blue team doesn't know about them, they're not monitoring those services, right? Also, are you compliant for regulatory reasons? If you have very specific controls and you write very detailed contracts with your cloud provider that we will have this kind of data retention and this kind of security, if someone gets tired or just decides, you know what, I'm going to go spin up my own thing on my personal credit card and stand up my work server here because it's easier and faster and I know this platform better, it's probably not in scope for any of those kinds of rules that you're required to be following. And maybe you've even blacklisted a vendor, but your users are getting around it by using personal credit cards or things. These are all things that can happen and are kind of terrifying. So you want to make sure you have tight control over what clouds are being used, monitor your network to see what clouds your network is talking to. Are you expecting traffic to those networks? Does it look like users are trying to circumvent your policies? All right. So those are things we find. So how do you stop it, right? I've got just about 10 minutes left here, so I'm going to run through these. These are just a variety of things that make my job way more difficult. So this is how you stop a red teamer. By stopping a red teamer, you're stopping real world attackers too. So this is really important. Again, a lot of these are just security best practices, but they do make my life as an attacker much harder. And I'm in that weird position where I actually want my job to get harder every day. So number one, monitoring, right? This is just critical to making sure that all of the things you're doing are actually working, right? You want to see if an attacker is getting in. The best offense is a good defense. We've all heard that. It's really true. You want your defenders watching your attackers. You want them watching your red team too. You want to see what they're seeing, see what they're not seeing. It's also important to the monitoring team be able to act. It's one thing if they can see what we're doing, but it's really much better if they can then take action and evict us. So don't just see the logs, but also be able to disable accounts or change firewall rules or anything like that. They need to be able to have a quick action to be able to stop us and not just watch us take our axe. Another thing is you need to make sure your blue team has visibility across the whole graph. And this is going back to a quote from John Lambert, who's another Microsoft security executive, really bright guy. He said a couple of years ago, defenders think in lists and attackers think in graphs. And the idea here is defenders often are looking at a list of things they're defending. They have a list of firewall rules. They have a list of servers they need to protect. They have a list of ports they're monitoring, but they don't think about the whole platform systemically. Whereas attackers do. Again, right, I talked in the beginning about how I'm not coming into attack where, I care that I'm attacking team X. What I really want is I want to steal that financial document. That's, the key thing that I'm after. It's going to make me a bunch of money on insider trading type things. Like, that's what I'm going after. I don't care whose team I have to go through to get it. And so if your blue team is thinking about the paths to get to that document, just like an attacker is, they're making sure they have the right controls across the entire plane of the enterprise, not just, is this one set of servers compliant for our monitoring? And finally, you want to have alerting on a single pane of glass. And so the idea here is, if your blue team has to try to find attackers across 10 different platforms, right? You have one monitoring service for your cloud. You have another one for your email function. You have another one for your Active Directory servers. You have another one for all these different services, right? If you're constantly clicking through all these different screens, you're going to miss some alerts. And you're not going to be able to correlate as easily, hey, there was an alert in this system, which then led to an alert in this system. The attacker must be moving through that path. So you want to make sure you've centralized all this monitoring into just one view for your defenders. Next thing is multi-factor authentication. I'm sure we're all very well familiar with this. Just make sure you're using it, right? If I can just brute force a password or guess a password or get a password from a breach that was used somewhere else and then replay it in your network and it works there too, that's really bad. I've now got access to all this stuff. Turning on MFA is great. It makes it way harder. I now need to try to get that token somehow. It's not impossible. You can still phish MFA tokens if you do it well, but a lot of times they're super time limited. You can't do very much with them. They're very hard to capture. And then there's also other kinds of MFA as well, like biometric MFA or having other kinds of tokens. Trying to get any of those is just so much harder. Finally, make sure you're using MFA across all your services. And so it's common to put it on your key services, but if you have a whole bunch of other web services that don't use MFA, maybe I can still get into those using like a password guessing attack, and then from there start pivoting through and actually gain access to more resources. So it's critical that you do it across your entire enterprise. But even better than just making sure you're doing MFA everywhere is using a unified identity solution. And so the idea here is, if you're trying to implement all your corporate policies around password management, password policies, and MFA everywhere, and doing that on a one app, like app by app basis, you're never going to get there. It's much easier if you can do it in one place and make sure that your policies are being applied everywhere. And so using some unified single sign-on solution that works across your enterprise, across all your cloud providers, across all the resources is really important. It'll get rid of that patchwork of user policies and requiring users to have multiple passwords to access multiple sites. It also makes provisioning and deprovisioning easier. In the context of security, deprovisioning is really important, right? You want to make sure when you disable someone's account, they're terminated or something, they leave the company, that you've now disabled their access not just to their workstation, but also to all those cloud resources they had access to and maybe were administrators of. You want a central source of logging and monitoring from this too. That just makes it way easier for your blue team to look through these logs because it's one common place. They're not getting logs from 50 different sources. You also gain additional security benefits, like maybe get conditional access from your unified identity solution that you didn't have on a legacy authentication platform. Administrator account hygiene, again, this is kind of common sense, but using a lot of the best practices the industry has come up with over the last decade or so, just to really reduce what an attacker can do. Just enough admin, making sure people aren't admin more places than they need to be to get their job done. Just in time admin, making sure that a user's account doesn't have permission 24 hours a day, but only when they're actually making that change, right? You can be a standard user most of the time, but then you get elevated into a privileged role just for the 20 minutes a day or something where you're actually doing that really key administrative function. Even better than that, one thing our company's found is super successful is using alternate accounts. And so if you have your users using the same account for administration access as you are for productivity, you've got a problem, right? Because now I can phish you. If I can phish that account, I can get in using an alternate account. So I have one account that I use for email and Word and Facebook and all that day-to-day stuff, and then a second account that's only used on key servers to do admin work. It's now much harder for an attacker to bridge that gap and get that second account. To make that even harder, we recommend using the privileged access workstation model. There's a whole bunch of documentation we've published on this. The idea is for this really key administrative work, give those users even a separate workstation. Make sure that workstation is totally locked down, way more draconian than the user would accept for their day-to-day machine. Whitelist all the applications, turn on all the security controls, but that is just a terminal only for doing this administrative work, nothing else. And so they're not using that same account, on the same machine that they're going and playing games on, that kind of thing. And finally, password diversification. Make sure you're not using the same admin password across your entire environment, because once you steal it in one place, you use it everywhere. Exercise zero trust. So zero trust is a big talking point. There's been a lot of discussion about this over the last couple of years. There's a bunch of different aspects to it. Microsoft has a great paper. I'm sure Mark will be happy to talk to you in Slack about it for a lot of time. I'll even drop a link to the paper in there. There's different aspects to this. One thing we like to do is assume breach, right? If you were previously assuming that your corporate network was secure and everything in it was trusted, don't do that anymore. Assume that an attacker has gotten in. If you make that assumption, what does that change about how you're managing your environment? It's really important to think about, especially right now, what does your network look like now? How has it changed? If I asked you 3 months ago, how many of your users were connected to VPN? How many users were working from home? How many users had personal laptops they were using or their personal phones they were using to connect to corporate resources? I bet the number would be way different than it would be today. And so just that scope of change and the change of your environment, making sure that you're accounting for all that and not trusting devices that you shouldn't. And finally, defense in depth, right? You're making sure that you're applying these security controls at every step of the way, making it way harder for me to get in than just saying, okay, well, we've got a firewall, so we must be good. And then the very last one is user education. It's critically important that you train all your users for security, not just your IT staff. Make sure your users are aware of all these different attacks so they have a chance of protecting themselves. Emphasize the importance of using unique passwords, not reusing a password across all their personal sites and their work accounts. Emphasize the use of MFA even on personal sites. Also provide phishing simulation attacks. My team has found that one of the key indicators for whether a user can detect if they're being phished or not is if they've previously been phished. And so rather than waiting for them to get phished by an attacker and realizing the problem, phish them using a simulation tool. There's a bunch of different phishing simulation platforms out there. Run a campaign, see who gets phished, and give those users on-demand training about phishing, right? If they click on that link, take them to a training page and say, hey, you just got phished, but don't worry, it's okay, it was us. And don't be mad at us, we're just trying to help you be better, right? Here are some things you could have seen that would have let you realize that this was a phishing attack, and maybe you won't make that mistake again in the future. Also really emphasize that it's okay to make a mistake as long as they report it, right? It's okay if you get phished. Everyone gets phished. Even security professionals can get phished if the phish is good enough. But as long as you know how to report it, make sure all your training is emphasizing what the right methods are to report these issues in your organization. Make it really easy for users to send you a report if there's something that went wrong. And then now your blue team can start acting right away, right? You don't have to wait for 50 users to get phished. You get a report on the first one. They can take action, and hopefully those other 49 never even get the phishing mail because you've blocked it before they can even see it. All right, that's all I had. Thank you so much. Appreciate you all being here, and I'll be in the Slack channel to answer some questions, and hope you all have a really good rest of your summit and good trainings.
Well, that was tremendous, Matt. Thank you so much. I'll tell you, I even learned things. And one of the things that I've enjoyed about your presentation is just hearing how you talk about some of these common security problems. So while we still have you, we do have a couple questions that came in through chat. The first one is from Chin Chen. And is there a ratio of the number of red team people versus blue team people, folks, that is typical in organizations?
I think that's going to vary a lot across industries and a lot across, how big your company is. A lot of companies clearly can't afford to have their own offensive security teams or very large offensive security teams. And so I will say the blue team is always bigger, right? You want a lot more monitoring folks than you need offensive security folks. You can also outsource some of the offensive security work. There are a lot of companies that do contract work if you can't afford to have your own offensive security teams. Yeah, it's hard to give a solid number there. I'd say probably at least 5 to 1 blue to red, but it's probably even more than that. I don't know the actual numbers that we use, but definitely want more defenders than red team for sure.
I also appreciated what you had to say about the trend toward using purple teams. So we have another question, and this is from an anonymous attendee. If you're conducting a red team assessment on your environment, or possibly on another environment that you've been engaged to do work on. How do you manage the possibility of virtual machines no longer having the same public IP address?
Yeah, that's a really good question. One of the things we have to do in scoping that's a bit different is I think there's a lot less black box testing in cloud testing. Black box testing is where you don't have a lot of background on what you're testing. You're told to just go after this objective and not given a lot of information. You really can't do that in the cloud just because you're trying to meet all those rules of engagement and make sure you're not violating anyone's space. And so we can no longer do that same level of just blind go in and start attacking things. We have to work really closely with the teams we're attacking. Maybe we don't work with the engineers on that team because we don't want to give away that they're being tested. Sometimes you see behaviors change because of that. But at least work with the management and say, okay, give us your IPs, but also, monitor this. Make sure, nothing changes the environment. If you're spinning up servers or bringing them down, let us know when that happens because, we need to adjust our scope during the engagement. And so just being really collaborative with your client is super important for that kind of testing.
And then can you talk about, well, how does the red team fit in the general context of a tabletop exercise? Do you guys even do tabletop exercises still?
Yeah, we do. And we can help with threat modeling, right? We see a lot of these threats. We know a lot of the attacks. And we get different perspectives, right? We'll sit down with the blue team or the teams we're doing like a threat model with, and they might know the threats, but they might not think through how does that particular threat apply to my application, or how could two of these different threats be leveraged in tandem to get further into our, further access into our application. And so having a red teamer there just to provide that kind of, malicious eye to things is often pretty useful, I find, for teams.
And then one last question before we move on. Is there a distinction in some organizations between an enterprise red team and a product or service-centric red team?
Yeah, I mean, there's definitely different perspective there in terms of what your main objective, what you care about is, right? Our product red teams care about protecting the product. They want a super secure product. They want to make sure Windows or Office or Azure is secure for everyone. They want to make sure that service itself isn't getting compromised. Just like I'm sure if you have a product team that's looking at the security of a product, you want to make sure the thing you're selling is good and secure for all your customers. For me, my customer isn't our customers. My customer is my company. I'm making sure that the company as a whole is itself secure and not getting breached. And so it's just a different outlook on who you're protecting and what the focus is.
Have you found that your tool set has changed for the cloud?
It has. Again, you need to make sure that your tools scale properly. When you're doing things with thousands of servers, you need to develop much better automation than just running a script on your box that's single-threaded, things like that. And so being aware of that, it changes. Again, thinking about that graph that I talked about too, making sure your tools can think in graphs is really important. So we see a lot more use of things like Neo4j in storing the data about our attacks because we can actually graph out our entire attack chain through that.
I really like that insight that you said that defenders think in terms of lists, attackers think in terms of graphs. So again, thank you so much. There's one other question, but it's a long answer and it's slightly off topic. So I'm going to paste that into your hallway. So everybody remember that Matt will be in the hallway for about the next 30 minutes. And if he's like me, he'll probably check it throughout the summit. If anybody has additional questions for him, go ahead and paste them to him in Slack.